This presentation is a summary of my research on advanced air mobility. We see a lot of research in this area focused on urban settings. So to fill that gap, this research focuses on rural logistics. So I'm Dr. Raj Brijlal from the Upper Great Plains Transportation Institute of North Dakota State University. I hope you find this presentation both interesting and informative. Let's start by defining advanced air mobility, or AAM. It is the use of new electric or hybrid aircraft that can take off and land vertically to transport people or cargo. And these aircraft are similar to those that are illustrated on the left in the figure over there. And the problem is that even though freight transportation is essential for rural communities, transporting goods using heavy vehicles like trucks places increasing pressure on roads, bridges, and logistic systems. Delivering time-sensitive goods to dispersed communities in rural areas often require long truck trips. But at the same time, progress in AAM is making these new types of aircraft capable of operating at smaller airports and regional facilities. So in this study, I examined whether these aircraft can complement traditional trucking to improve logistics performance, while at the same time reducing stress on ground transportation infrastructure. So the focus is not replacing trucking entirely, but rather in identifying targeted opportunities where aerial freight can provide measurable benefits. Rural freight logistics face several challenges. First of all, communities are spread out across long distances with low population density. This means that trucks must travel long distances to deliver relatively small quantities of goods. These repeated trips accelerate pavement wear and increase bridge loading, especially on infrastructure designed for lighter traffic, and that includes unpaved roads and two-lane highways. So freight activity tends to concentrate near logistics gateways such as airports, seaports, and distribution hubs. This concentration creates congestion and safety risks. Many high-value goods, including pharmaceuticals and hazardous materials, also require reliable and rapid delivery. So together, these conditions create an opportunity to explore alternative logistics strategies, especially for rural areas. The solution that I proposed is a targeted deployment of AAM aircraft for specific freight missions. So rather than replacing trucking, these aircraft complement ground logistics by transporting selected cargo on short and medium-length routes. High-value and time-sensitive commodities are especially suitable because reliability and speed justify the cost of aerial transport. The key advantage of a targeted approach is that early deployment can rely largely on existing aviation infrastructure, such as regional airports and hospital aviation facilities. This approach allows logistics systems to expand capacity without requiring major new infrastructure investments. The analysis combined 4 key areas: technology assessment, freight market analysis, infrastructure evaluation, and regulatory review. The study found that infrastructure availability is not the primary barrier to the deployment. Many regions already have multiple airports. The map on the left shows the location of regional airports as little dots, and the colored polygons are freight center markets, and these are major markets in the United States. You can see that these airports have a nominal separation of about 100 miles, and that's within the operational distance for current technology in electric or hybrid cargo aircraft, and it'll only get better as battery technologies improve. Now, this landscape creates repeatable routes that are suitable for aerial transport. Even though current electric aircraft operation is limited by battery, energy density, and payload, these constraints still align well with short and medium-range freight missions. The plot below the map shows that high-value goods such as electronics and pharmaceuticals are well positioned for initial high-demand markets. The figure on the left illustrates a vision for linking long-haul, middle-mile, and last-mile logistics in advanced air mobility. The details of this are in the article below. Just scan the QR code to get the link. The analysis also presents several measurable improvements when AAM is deployed selectively. First, replacing repeated truck trips with aerial transport can reduce heavy vehicle exposure on vulnerable roadways and rural areas. Second, reliability improves for time-sensitive goods because aircraft can bypass congestion and long-distance driving. Third, aerial systems achieve higher utilization than trucks on low-volume routes, which reduces inefficiencies in freight networks. Together, these improvements create a multimodal logistics system where we can use each mode where it performs best. I recommend that deployment follow a staged roadmap. So we have a near term, a medium term, and a long term. In the near term, pilot projects can demonstrate AAM operations on repeatable freight routes that connect existing airports and logistics hubs. These early deployments should emphasize monitoring and performance evaluation to measure infrastructure impacts, logistics reliability, and operational efficiency. The figure on the left illustrates how we can do this by linking data sets with infrastructure planning. Again, the details are in the paper with the barcode that you can access. In the medium term, operational standards and airspace integration procedures will need to mature as we scale AAM operations. And over the long term, improvements in aircraft technology and regulatory frameworks will enable broader deployment. This will expand the role of AAM as a complement to ground freight systems. To conclude, AAM represents a practical opportunity to modernize freight logistics. This research showed that the greatest value comes from targeted deployment, where aerial transport provides clear advantages. By shifting selected freight movements from roads to aircraft, transportation systems can reduce infrastructure stress while also improving reliability and safety. I believe that with thoughtful pilot deployments, ongoing monitoring, and coordinated policy development, AAM can become a scalable component of future freight mobility systems. So to learn more about me and my research, please check out my website shown below, and thank you for viewing this presentation.